Hey folks, in this lecture we're going to learn how to manage disk partitions using both MBR and GPT partitioning schemes in Red Hat Enterprise Linux 9. This is an essential skill for Linux system administration, and it's directly tested in the RHCSA exam. By the end of this lesson, you'll understand the difference between MBR and GPT, and you'll be able to create, format, mount, and persist partitions using tools like fdisk and parted. Let's start with the basics. Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you. A partition is a logical section of a disk. Without partitions and file systems, the operating system cannot use the storage. Now, Linux supports two major partitioning schemes, MBR and GPT. MBR stands for Master Boot Record. It is the older standard and supports a maximum of 4 primary partitions and disk sizes up to 2 terabytes. GPT stands for GUID partition table. It is the modern replacement for MBR, supports up to 128 partitions, works with UEFI systems, and allows much larger disk sizes up to 9 zettabytes. In the RHCSA exam, both MBR and GPT may be tested. MBR is managed using the fdisk utility, while GPT is typically managed using parted. MBR is fine for small or legacy systems, but GPT is the preferred choice for modern production environments. Let's begin our demo by first adding a new disk. I open the VMware settings of my virtual machine and go to the Hard Disk section. I click Add, select Hard Disk, then click Next. I choose SCSI as the type, click Next, and select Create a new virtual disk. Then I set the size to 5 gigabytes and finish the wizard. I click OK to apply the changes. Now I restart the VM and log in using the user Oliver and enter the password to access the system. To verify if the new disk has been added, I type the command lsblk. This lists all blocked devices. I can now see a new disk named SDA with a size of 5 gigabytes. This confirms the disk has been successfully attached. Next, I type sudo fdisk-l. This lists detailed information about all available disks and their partitions. I verify that SDA is the correct disk, and I make sure not to touch the disk named NVMe 0 and 1 because it contains the root file system and the OS. We'll only be working on SDA, which is our test disk. Since we're creating an MBR partition table, I type the command sudo parted/dev/SDA. This opens the Parted interactive tool. Inside Parted, I type mklabel ms-dos to create an MBR label. Then I type quit to exit Parted. Now I type sudo fdisk/dev/sda to launch the fdisk tool on our disk. Inside fdisk, I type the letter M to view all available commands. This shows me a list of options including how to create new partitions, change types, delete, and print partition tables. To create a new partition, I type N and press Enter. Then I press Enter again to accept primary as the partition type. I press Enter once more to accept the default partition number and again to accept the default first sector. For the last sector, I type +1 capital G to make the partition 1 gigabyte in size. Now I want to confirm if the partition was created correctly, so I type P to print the partition table. It shows that partition 1 has been created with the Linux type and a size of 1 gigabyte. I type W to write the changes and exit fdisk. Next, I type sudo part probe to inform the kernel of the new partition table. I also type sudo udev adm settle to ensure all udev rules and events are settled. These two steps are important so the OS properly detects the new partition. I run lsblk again, and now I can see SDA1 has been created under the SDA disk. To double check, I type sudo fdisk -l/dev/sda. It shows the new partition as SDA1, 1 gigabyte in size with the correct type. Now I need to format the partition with a file system. I type sudo mkfs.ext4/dev/sda1. This creates an ext4 file system on the partition so it can be used by the operating system. To mount the partition, I first create a directory as a mount point. I type sudo mkdir/mnt/mbr disk. Then I mount the partition using the command sudo mount /dev/sda1/mnt/mbr disk. To confirm the mount was successful, I type df-h. I can now see that /dev/sda1 is mounted on /mnt/mbr disk. Now I want to make this mount persistent across reboots. I type sudo blkid/dev/sda1 to get its UUID. This is a unique identifier used for stable mounting. I copy the UUID, then open the fstab file by typing sudo nano/etc/fstab. At the bottom of the file, I paste the UUID without quotation marks, then add the path /mnt/mbr disk, the file system type ext4, the defaults option, and then 0 space 0. I save the file with Ctrl+X, then press Y and enter. Now I unmount the partition using sudo umount /mnt/mbr disk. To test if the fstab entry works, I type sudo mount -a. If there are no errors, it means the entry is valid. I run df-h again, and I see that SDA1 is mounted again under /mnt/mbr disk. This confirms our persistent mount setup is working correctly. Now we'll repeat the process using GPT. I type lsblk again to see my disks. Currently, I only see SDA, so now I go back to VMware settings and add a second disk of 2 gigabytes. I follow the same process, add SCSI, new disk, set size to 2 gigabytes, finish, and click OK. I reboot the VM and log in again with user Oliver. Once logged in, I type sudo fdisk-l, and now I see a new disk named SDBE with a size of 2 gigabytes. Since this time we're using GPT, I use parted. I type sudo parted/dev/sdb, and inside parted, I type mklabel GPT and press enter. Then I type quit to exit. Now I launch parted again by typing sudo parted/dev/sdb. Inside parted, I type mkpart to create a new partition. It asks for a name, so I type primary. Then it asks for the file system type. I type ext4. For the start, I type 1 capital MIB, and for the end, I type 1001 capital MIB. Then I type quit to exit parted. I type sudo partprobe to update the kernel and ensure the partition is detected. Then I format the new partition using sudo mkfs.ext4/dev/sdb1. The file system is successfully created. I create a mount point using sudo mkdir/mnt/gpt disk. Then I mount it using sudo mount/dev/sdb1/mnt/gpt disk. I confirm the mount by typing df-h, and I can see /dev/sdb1 is mounted on /mnt/gpt disk. To make this mount persistent, I type sudo blkid/dev/sdb1 to get its UUID. I copy the UUID and open the fstab file using sudo nano/etc/fstab. At the bottom, I paste the UUID, then the path /mnt/gpt disk. The type ext4, the default option, and 0 space 0. I save the file using Control plus X, then Y, and press Enter. Now I unmount the partition using sudo umount /mnt/gpt disk. I type sudo mount -a to test the fstab entry. No errors are shown, which means it worked. Finally, to confirm, I type df-h and see that SDB1 is mounted again at /mnt/gpt disk. This confirms the persistent mount is working properly. Remember, simple mount commands only work until the next reboot. To keep partitions mounted permanently, you must update the fstab file using the UUID. And with this, we've completed our practical session on managing disk partitions using both MBR and GPT. You've learned how to use fdisk and parted, create partitions, format, and mount them, and make the mounts persistent. These are vital skills for RHCSA and real-world Linux system administration. Keep practicing, and I'll see you in the next one. And let's keep learning together.